Hello, students. This is Mr. Bornheimer, and I am going to kind of walk you through today's notes. These notes are going to be focused primarily on our middle school chemistry unit, Unit 1, and we're going to be looking mostly at measurement. Okay, so a couple of cool things about this topic and kind of reviewing everything that we've talked about so far. We've really tried to take a look at what scientists, how they think. And one of the things that is really important to a scientist's way of life is how they actually collect information. So I think it's important for us as students to try to have a better understanding of what that looks like. Okay. Now, over the course of this video, you're going to notice that I'm going to be here in this corner of the screen. And if you kind of look down here in that whole area, you're going to see all the notes. Okay. And there may be a couple of slides where the notes get cut off. So listen carefully to what I am saying so that you can catch everything, even if there's a little bit of the words cut off. Okay? All right, here we go. Let's go ahead and if you draw your attention to the notes here, we're going to take a look at measurement. Okay, so measurement. Well, what is it exactly? Okay, the first thing you have to understand about measurement is that you have to have a standard with which to compare. Okay, so for instance, I have my handy dandy measuring tape. Okay, I love it. It helps me do a lot of great things. Okay, so in order to make a measurement with this, I have to know the standard it uses. Okay, it doesn't help me if it's using a standard that I'm not familiar with. Okay, here in America, we use the English or American system, and so you'll see right on this tape measure that there is FT or feet. That automatically tells me that this tape measure is going to measure things in relation to feet. And because there's feet involved, and I'm not talking about your feet inside your shoes, I'm talking about the unit, the foot, okay, like what we measure with a ruler, there's going to be inches involved as well, okay? So that's the standard we're talking about. But then in using that standard, we have to have a tool, tape measure, that we use to make the measurement. Okay? So, in order to be a good scientist, in order to make good measurements, we have to know how to use our tools. And we have to know how to read our tools. This would do me no good if it had hieroglyphics on it because I would not be able to read it. Okay? It has to be in some kind of standard that I am familiar and that I have practiced using. Okay? So that's what's so important about measurement. And hopefully, when we're done with this, you'll be able to recognize just a few more units of measurement that scientists use all the time to make measurements. Okay? All right. The first thing we also have to understand is that because of the way we are designed, okay, we have some inherent limitations. All right. So this is going to seem a little weird because you're watching this video, but what I want you to do is I want you to take and put your finger out in front of your face. Okay? So here's my finger, and you can see that I'm going to put it way out in front of my face. Okay? Now I want it to be about arm's length away. And what I'm going to do is I'm going to look at my finger with both eyes. I'm going to focus on my finger. And I want you to notice what it looks like beyond your finger. Okay, you're not focused on the beyond, you're focused on your finger. But if you can kind of use some of your peripheral or some of that not focused portion of your vision, you can see that some of the images in the distance, well, they kind of look like they've duplicated. It's kind of like growing. But when you focus on the distance, all of a sudden, whoa, your finger, you now have two of the same finger. It's like, oh my gosh, you have two hands, but you don't, but you do. Well, you do, but now you have like two of the same thing. It's two of the same fingers. So you put it out there, you look at it, and you can, if you switch back and forth between focusing on what's in the distance and focusing on your finger, you can make your finger turn into two. All right? This has everything to do with the fact that we have two eyes set apart on our face. Okay? We are not cyclopses, I've checked. And in doing so, I've noticed that all of you, yes, all of you, even every one of you, you know who I'm talking about, have two eyes, not one, two. So when we're looking at something, okay, we have this kind of funny thing that happens. Sometimes, depending on how we're looking at it, it can look a little weird. All right, this is called parallax. Okay, there's another way to test this. If you put your finger out in front of your face and you close one eye and then you quickly close the other and then you kind of go like this. It's kind of funny looking. Close one eye, then close the other, and then close one eye, then close the other. So it's kind of like this. Okay, and it kind of even makes a funny noise. You'll see that your finger looks like it's shifting back and forth. That also is the same effect, parallax. So when we're looking at something, and we're trying to measure something, we have to be aware of the fact that depending on how we're looking at it, it might look slightly different. And so we need to take that into consideration. We sometimes have physical limitations in our ability to observe the world in which we live. Now, if you're an astronomer, this idea of parallax is really important, okay? Because it helps us measure how far away stars are. Yes, as a matter of fact, we can measure stars and how far they're away by using this thing called parallax. Okay, it's a little bit beyond our level right now, but just know it's something that is very useful to scientists. We can take advantage of this neat feature of shifting objects based on the way you look at them. Okay? All right. Now, a couple things about this next section of notes. There are going to be kind of titles at the top, like right here. Those are the things I want you to take and write down. Okay, all of the stuff below, unless I say otherwise, is just there for me to talk about. And it's good for you to be aware of it, but the main key ideas are going to be at the top. Okay, now if I highlight something down below, that means that it's probably important and you should write it down. Okay, and if you don't necessarily understand what it is, make a little note by putting a star, and that way when I get back, you can ask me questions about maybe something you didn't quite understand the first time around. Okay? All right, so in looking at this, SI units, okay, what we should understand is that SI units are a series of units, and if we recall, those are standards that were adopted many years ago, as a matter of fact, in the 1700s, 1795. Okay? One of the major benefits of SI units, or the metric system, as we call it, one of the major benefits is that the metric system is based on powers of 10. Okay? And while that might not make a lot of sense right now, I'll give you a brief example of what I mean. It means that we can convert between units really easily. In America, we don't have it that easy, okay? We have to know that there are 12 inches in a foot, there are 3 feet in a yard, okay? And these are kind of what we call abnormal numbers. But in the metric system, you have some really simple numbers. You have 1 meter, okay? You have 100 centimeters in a meter. You have 1,000 millimeters in a meter. Okay, do you see how those are just powers of 10? Okay, all right, 1 is just 1/10 of 10. All right, 100 is 10 times 10. 1,000 is 10 times 10 times 10. Everything can be related to 10. 10 is so easy to work with. So that's why the metric system is so powerful. And when you get really good at using it, you can convert between really big numbers and really small numbers very quickly. That is the huge benefit. Now, there are several standards that we're going to be looking at. Okay, there are 7 base units primarily in the metric system. We won't be using all of them, but I'm going to kind of talk through many of them today. Okay, so first of all, the units that we're going to be primarily focused on are the ones that I've put kind of like in bold for you. Okay, so length is going to be really important. Time is going to be really important. Temperature is going to be crucial in our study of chemistry. That's one of the things, as is mass. Okay, so these things are going to be really important. So we're going to want to make sure that we understand them. And volume. When you get into high school, you're going to focus primarily a little bit more on quantity and maybe light, but especially quantity. So we're going to talk a little bit about that to introduce you to it in this series of notes. Okay. All right. So the question on the table is, how might you, as a person, define a second? So what I want you to do is take a few moments right now and maybe just talk with the person next to you and say, how would they define a second? Okay, go. Michigan. You should be talking. Hopefully that conversation's going awesome. Hot chocolate. It's delicious. All right. Bring it back. Here's what I'm guessing that you probably came up with. All right. Some of you probably said, well, there's 60 seconds in a minute, or it's that little number, it's those little numbers on a clock, or it's that little second hand that goes tick, 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 tick on a clock. Okay. But the fact of the matter is what is a second? What is time? Okay. At the beginning of time, did God create clocks? No, he didn't. Time is something that we kind of invented, that we kind of came up with to help us explain the world around us. So the question on the table is, how do we define it? Okay? And that's what we're going to talk about. So, time. Believe it or not, when we have to define a standard, a unit, feet, inches, seconds, meters, etc., we actually have to define them using things that we can observe. And if you remember from our discussion today and yesterday, observations are things that we do with our senses. Okay? So originally, they defined a second as being a portion of a day. Okay? This is a really big number. They divided a day up into 86,400 pieces, and they said one of those pieces is a second. However, they found out many years later that that was not the best definition, because the days are not all equal, for one, and every so many years we have to adjust our clocks and calendars, like on leap year, to make it all work. So they then came up with this really crazy definition for a second as the duration of 9,192,631,770 periods of the radiation corresponding to the transition between two hyperfine level of the fundamental state of the atom of cesium-133 isotope. I know it's so exciting, but I'm sure you don't probably have any idea what that means. Okay, many people don't. But what that means, the big picture here is that there's actually something out there that scientists measure and use that as the definition of a second. And so what we do as scientists is we find things in nature, real objects, real things, real occurrences, so to speak, that we can use as definitions for our units. This way, we can check our units every once in a while to make sure that they're right. So time is really the duration between two occurrences. I clapped twice. The first clap was the first occurrence. The second clap was the second occurrence. We would say that time existed between those two occurrences. Okay, so really what we're saying is something happens, then something else happens, and in nature, there's something that happens and we defined it as a second, and we use that definition all over the world in every country and in every language to represent time. So that's how we do things as scientists. Okay, so that's how time is defined. It's really kind of crazy. You really just need to know that it's the duration between two occurrences. Now remember, this is at the top, so it's something that you should probably write down and remember. Okay? Length. All right, so getting back out the tape measure here. Length is something that's really important. Okay, we use it all the time. You know, I have meter sticks in the classroom, and we use those to measure things. You have rulers that use those to measure things. Tape measures to measure the length of something. Okay, in the metric system, the SI unit is the meter. Okay, And it was actually originally defined, remember, it's something physical, something real, something we can measure. It was actually originally defined as 1/10 millionth the distance between the North Pole and Paris, France. But again, we realized that that's not a very good definition because the continents move, tectonic plates. So Paris actually moves a little bit. So it's not very refined. So, and as you can see here, there are some other things that we were able to use to define a meter. Okay, and so that's what we've done. We've redefined it so that it's very specific to a naturally occurring situation. And so really what we've come down to is that a meter or length is defined as the distance between 2 points. So on here, I might say that the distance between the 9-inch mark and the 10-inch mark is 1 inch. Here's point 1, here's point 2, and so there has to be a distance between these 2 points. Okay, so that's how we define length. We have to have at least 2 points. And this will actually come back again, and you'll see this when you start talking about distance and length in geometry in just a couple of years. Okay, temperature. Temperature is one of my favorites. Okay, and this is one of those definitions that might get cut off at the top. Okay, so I want you to kind of, I'm going to rewrite it down here near the bottom, especially the bold words. Okay, temperature is the measure of the, and here's the key idea, average energy of motion. We actually call the energy of motion kinetic energy. We're going to talk more about that later in Unit 5. Okay, so the average energy of motion. And that, what that looks like is we zoom in and we measure all the energy of the atoms in an object, and then we average it. Okay, and that tells us its temperature. All right, now over time, we've come up with different scales like Celsius and Fahrenheit. These are 2 you're probably familiar with. But there is another unit which we're going to use, and it's actually the one that scientists use, and it's called Kelvin. Okay, so that's the one that we primarily need to focus on, and I would recommend that you write that down. You may see it again on a test, I don't know, so make sure you take note of it. Mass. Love mass. Mass is how much stuff is in an object. Okay, so this apple has mass. There's something in it. This coffee mug has mass because it's made of something. Okay, and it's got Michigan on it, which makes it awesome. This stylus has mass because it's made of stuff. These sticky notes are made of stuff, so they have mass. This pepper shaker has stuff in it, pepper. Therefore, it's got mass. So, therefore, it is made of matter and we can measure it. Okay? So, the SI unit for mass is the kilogram. Okay? This is actually, what this actually means is kilo, which means 1,000 grams. All right, which is a unit of mass. So the kilogram actually means 1,000 grams. Okay, and that's a very, very small unit of measurement. Okay, so that's a kilogram. I weigh about 75 to 80 kilograms. Okay, if you were to actually measure me here on Earth, that equates to a little bit over 200 and some odd pounds. All right, so that's what we're looking at here. We're looking at how much stuff I'm made of. And I'm made of a lot of stuff. All right. Now, believe it or not, the standard for this that scientists use to make sure that everyone's on the same page is a block of metal sitting in France. That's right. If you look at the third bullet point here, it's a piece of metal kept at the International Bureau of Weights and Measures in France. There's a piece of metal in France that is our standard for the kilogram. All right, so it's a physical object that we all use to make sure that everyone has the same standard for the kilogram. All right. Which weighs more, a ton of feathers or a ton of lead? Okay. Hopefully you came up with an answer. They're the same. Hopefully you figure it out. All right, moving on. Because we're talking about mass, how much matter is in something, all right, it's really important that we kind of make a difference between mass and weight. Okay, there's a really important distinction that needs to be made here. So, the measure of the amount of matter in an object, okay, is what we call mass. All right, that does not change. You could be on Jupiter, you could be on Neptune, you could be on Pluto, Mercury, Venus, Mars, you could be in a spaceship. The stuff you're made out of is not going to change. Okay, you're going to have all the same number of atoms in you, you're going to have all the same number of molecules, you're still going to be made of approximately 6 elements on the periodic table. Okay, you're not going to change in matter. However, our weight, okay, actually doesn't depend on what we're made out of. Believe it or not, our weight depends on where we're at. Okay? So we would say that our weight actually can change from place to place. All right? So this actually is due to something called the force of gravity. You're probably familiar with gravity. It's what holds us here on Earth. And every large body of matter in our solar system and in the universe has gravity, even you and I. Okay, we just don't have enough of it to be measurable. The Earth, being a huge, massive block of rock and magma and all kinds of good stuff, it has a lot of gravity. So it actually makes it so that we have weight. Okay, the moon is also a big ball of rock, but it doesn't have as much rock, and therefore it doesn't have as much gravity. So on the moon, we actually weigh less because there's less gravity. So we would say that our weight is the measure of the gravitational force between objects. On the moon, the gravitational force is weaker, so we would weigh less. In space, when you're in a spaceship and you're going around the Earth or you're traveling to the moon, there's very little gravity, okay, that's holding you down, and so you're weightless. Okay, there's a little bit more to it, but that's kind of the big idea. On Earth, we weigh a lot more because Earth is bigger than the moon or a spaceship. And if we were on Jupiter, we would weigh a ton more. Not literally a ton, but a lot more. Because Jupiter is so much more massive than Earth. All right, and if we were on the sun, we would weigh like 600 times more than we do on Earth. So talk about gaining a lot of weight. Not mass, it'd be the same, but a lot of weight. So if you want to lose weight, go to the moon. You'll weigh about 1/6 what you do on Earth. Okay? So if you want to talk about an instant weight loss program, there you go. Okay? So that's the difference between mass and weight. One doesn't matter where you're at. You're going to be made of the same stuff, mass. One matters where you're at because of the force of gravity. And gravity changes depending on where you're at. Quantity. Okay, this is what we call a really neat thing. The quantity is the amount of substance something has. Okay? Now, in the scientific community, oftentimes in chemistry, we have to measure atoms. Okay? Well, the problem is that even on the tip of this stylus, there could be billions of atoms because they're just so small. And in those atoms are other particles, and in those particles are other particles. And so we're dealing with things that are so tiny that to try to measure all of them would be numbers that are huge, huge. So what a guy by the name of Avogadro did is he said, let's kind of group these into things we'll call moles. And we're not talking about the blind little creature that burrows through the dirt. We're talking about a number, kind of like a dozen. 1 dozen is really 12. Okay? Well, 1 mole is really just a much, much bigger version of a dozen. It's 6, 0, 2, it's about that many zeros. I think I might be 1 or 2 zeros over, but it's roughly that big of a number. So here's the idea. It's just a big number. And we use this number to represent atoms because there are so many of them in such a tiny little space. Okay, and so we have to use something like the mole. This is not something we're going to explore in great detail in middle school chemistry, but it is something that's going to be really crucial in high school chemistry. And it's something that I at least want you to have heard of, okay? So that when it comes up again, you're not like, oh, what's this mole thing? We're talking about creatures digging through the ground? Nope. It's actually more scientific than that. Now, to give you an idea of just how big this number is, just so you can kind of comprehend it, by the way, there's a correction here. It should be 10 raised to the 23rd power. Huge number. If you had 1 mole of marbles, this is how big this number is. It would spread over the surface of the earth and produce a layer 50 miles thick. Okay, so we're talking a lot of marbles. If you had 1 mole of sand, think of a tiny grain of sand, and you had 1 mole of sand, it would spread over the United States a layer 3 inches deep. Okay, so that's a ton of sand. I don't even like sand in my shoes, let alone everywhere else. If you had a mole of dollars, okay, you'd be thinking, all right, I got a mole of dollars. You couldn't spend it at a rate of $1 billion a day for 1 trillion years. That's how big this number is. Now, why this is so cool is because that means that the atoms that make up stuff are so numerous that we couldn't count them in lifetimes. So we have to rely on math and science to help us group them together so that we can actually use them and use math to solve scientific problems and experiments. So it's a huge number. And that's about all I really want you to kind of grasp from this for right now. Okay? All right. That's going to end this recording. I hope that if you have any more questions or concerns, you can always email me. One thing that I really want you to do in the next is make sure tonight, if you didn't catch everything, is to go back through and make sure you take good notes of the things that I wanted you to take note of. Double check the things that I highlighted and things like that. Like I said, if you have any questions, go ahead and email me. Otherwise, have a great day. This is Mr. Bornheimer signing off.